So, you're thinking of taking physics. I think that's a great choice. Let's find out a little bit more about what you'll be getting into. There are 3 different physics courses at our school. There's grade 11 university physics, grade 12 college physics, and grade 12 university physics. I'm going to talk about all of the courses in this one video because they cover much of the same content at different levels of depth, and I think that we'll differentiate in the video as needed. So what is physics all about? Well, the fact is that physics is about understanding the laws of the universe. And that means the laws from the very big, meaning at the scale of galaxies and the entire universe, right down to the laws that govern minuscule tiny atoms and the particles within them. That's a broad range of laws, and some of it's covered in a variety of different courses in our school. Generally speaking, physics is broken into 2 main domains, what we refer to as classical physics and modern physics. In grade 11 university physics, the focus is on classical physics, as well as in the grade 12 college program. In the grade 12 university program, you go into more depth into classical physics, but you have an opportunity to explore some of the more modern physics concepts that evolved after the 1920s, and that's the kind of stuff you would be familiar with when you hear people talk about Einstein and special relativity and understanding the atom and things like that. So classical physics is still incredibly vast. That's everything from detailed understanding of motion in all of its different aspects. That will be covering electricity. That means understanding light as well as sound and waves, water and water waves. That goes into concepts like energy and how we use energy in society, how we generate electricity. How it relates to climate change or energy crises that might be on the future. Our use of energy, good and bad, pros and cons, as well as its potential for destruction. When we understand modern physics at the grade 12 university level, then we'll be really diving into understanding the mechanics of atoms and molecules, quantum mechanics, elements of time and special relativity, and coming to understand a little bit more about the fabric of space-time, how gravity works, how black holes work, and things like that. So there's really a lot to cover, and I hope you'll understand that taking a course like this exposes you to concepts that in many cases you've never thought of before. These courses are inquiry-based courses, and by that it means that it's a student-centered approach. You're not going to find many lectures in a course like this because concepts need to be explored in a variety of different ways and discussed. There are many hands-on investigations, so you'll look forward to doing labs, collecting data, analyzing that data, and developing relationships within that data. You're also going to expect a lot of collaborative group problem solving. This is one of the central aspects of the physics courses at Jean Augustine Secondary School, is that we put a significant emphasis on group discussion and group interaction. So be prepared to talk about what you know and, more importantly, what you're struggling to understand. These conversations will be pivotal to your overall growth as a physics student. Now, Galileo, what is often referred to as the father of physics, once said that mathematics is the language of the universe, and the fact is it's true. The reality for you is that we do have to use a lot of mathematics in physics. And so if this is an area that you struggle or maybe you find some weakness, I don't want to initially deter you. Understand that this is a concept-based course, not a math-based course, but you will not avoid the mathematics. So while you might come to a deep understanding of the laws of physics, in many ways you demonstrate that understanding through the application of mathematics. For many students, if their math skills are not up to par, they can still be very successful in physics, but they have to be prepared to work a little bit harder, ask a few more questions, and certainly ask for extra help as necessary. And for many people, it's just a case of developing some basic math skills that for some reason or other they just didn't pick up along the way. Your teachers will be very supportive in this regard, so I don't want you to think that the math is a huge deterrent, but understand that you will not avoid it in this course. It's just central to what we do. Now, what can I say? This course, in my view, changes how you see the world. Right now, you're fairly ignorant, And I don't mean that in any sort of derogatory sense. The fact is, the world works a certain way, and the truth is, you probably just don't know how it works. You don't understand how electricity works. You don't really understand why sound echoes, or why roller coasters work, or why your cell phone works for that matter. There's a lot going on in there, and physicists have a very profound understanding of the world at this point in time. So, as you take this course, I can almost assure you that by the end of the course, you will look around and you will feel differently about the world you live in. You will notice things when you're driving in a car or going to an amusement park or watching a movie on a big screen. There are so many things about it that will come to life in ways you'd never noticed before because you just weren't paying attention to how it works or why it works, only just that it works. So I hope after this short presentation you're feeling inspired to take physics. I think it's an excellent course. I think it's worthwhile for every student to expose themselves to these concepts, and I think it will benefit you greatly, both in your understanding of the world, but also in your commitment to learning and making sense of the world with your peers. Looking forward to seeing you in physics.